Day 537 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3346, maximum frequency of an element after performing operations 1. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, hype, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums and two integers k and num operations. You must perform an operation num operation times on nums where in each operation you select an index I that was not selected in any previous operations and add an integer in the range of -k to k to nums of I. Return the maximum possible frequency of any element in nums after performing the operations. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, the first thing we want to understand before we get into these examples is what is the definition of frequency. It says the frequency of an element x is the number of times that it occurs in an array. All right, y'all. So now that we know what a frequency is, let's go ahead and take a look at these examples to make sure that we understand what's going on. So in example 1, we have our input nums equals an array of integers 1, 4, 5, k equals 1, num operations equals 2. Now, as you can see, starting out, each element in nums has a frequency of 1 because each element only occurs one time. So 1 occurs once, so it has a frequency of 1. 4 occurs once, it has a frequency of 1, and 5 occurs once, so it has a frequency of 1. The output is 2, however. So if the output is 2, that means after following these operations, we were able to change the frequency of one of these elements to 2. So let's look at the explanation to see how they did that. It says we can achieve the maximum frequency of 2 by adding 0 to nums of 1, nums becomes 145. So the first operation, remember, num operations is equal to 2. That means we need to perform 2 operations. Now, since k is equal to 1, that means when we add an integer in the range of -k to k, that means in the range of -1 to 0 to 1, right? So that's in the range from k, which is -1, all the way up to 1. Boom. So in this case, we add 0. So we add 0 to nums of 1, which will be this 4, and it stays the same. So we keep it the same. Then our second operation, we add -1 to nums of 2, and nums becomes 144. So for our second operation, we add -1 to this 5, and now our array looks like this, 144. And when we have an array with 144, now 4 has a frequency of 2. And since 4 has a frequency of 2, 1 has a frequency of 1, that means 4 has the max frequency, which is 2, and we want to return the maximum possible frequency, right? So if 2 is the maximum possible frequency, then that's what we're going to return, and our output is 2. So, so just in case that didn't make sense to y'all, let's take a look at example 2. So in example 2, we have the input nums equals an array of integers 5, 11, 20, and 20. This time k equals 5 and num operations equals 1. The output is 2. Explanation says we can achieve the maximum frequency by adding 0 to nums of 1. So boom, once again, we just add 0 to this. It stays the same. 20 already has a frequency of 2 because it occurs 2 times, so the output is 2. As you can see, 5 still has a frequency of 1, 11 still has a frequency of 1, and so since 20 has the frequency of 2, then the output is 2. And you can see that since k equals 5, we can never get another element that is equal to 2 or greater than 2, right? If we add 5 to this, we'll get 16. 16 will still only have a frequency of 1. And if we add 5 to this, we'll get 10, and 10 will still only have a frequency of 1. Similarly, if we subtract, or up to 5, I should say, because we could add 1, 2, 3, 4, or 5. But either way, if we add 1, 2, 3, 4, 5 to this number or this number, we still won't get 20. And same thing with this with the 5 or 5 and 11, if we subtract up to 1, 2, 3, 4, 5, we still won't get any matching elements or duplicates, or we still won't get another element with a higher frequency because we only have one operation. So even if we subtracted 5 from this, we get 6, and 6 would still have a frequency of 1. If we subtracted 5 from this, we'll get 0, or anything up to 5, or we add anything up to 5. Either way, it's still going to have a frequency of 1 because we only have one operation. So the output is going to be 2 regardless, because 20 occurs twice. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. Now, the first thing we are going to do is we're going to sort the input array to simplify the range-based searches. So we're going to say let sorted equal nums dot sorted, and open up the parentheses like that. Then we're going to say let n equal sorted dot count, and then we're going to say declare a variable called max freq, set that equal to 0, and this will store the maximum achievable frequency. Boom. Then we're going to come underneath this and we're going to count how many times each number appears in the array by using a dictionary. So we're going to declare a variable called freq map. We're going to say colon, open up the square brackets for our dictionary. The key is going to be an integer. The colon is going to be an integer, and we're going to initialize it with a blank dictionary, just like so. So now we need to populate this freq map. So we're going to say for num n sorted, we're going to open up the brackets and we're going to say freq map, open up the square brackets, we're going to say num comma default colon 0, come outside that square bracket and say plus equals 1. So what this is going to do, so for each num and sorted, each time we see this num, we're going to count how many times we see it, right? So we're going to start the count from 0. That's what this default 0 means. That means we're going to start the count from 0. And each time we see this num, we're going to add 1 to this default value, and it's going to be stored in this array, with this key being the num and this value being the number of times it's been seen or it occurs. Boom. Now we need to create a set of potential target numbers, and each number can either remain the same or be transformed by plus or minus k, or up to plus or minus k. So for each num, we consider num minus k, and num plus k as possible targets. So we're going to declare a variable called candidates, and we're going to set that equal to a set less than int greater than, put the parentheses like that. Then we're going to say for num and sorted, we're going to open up the brackets and we're going to say candidates dot insert, open up the parentheses, pass in num. Then we're going to come underneath that, we're going to say candidates dot insert, open up the parentheses, pass in num minus k. Then we're going to come underneath that, say candidates dot insert, open up the parentheses, and we're going to say num plus k. Boom. Then we're going to sort the list of candidates target values for consistent processing by coming underneath this, and we're going to say let sorted candidates, we're going to set that equal to candidates dot sorted, put the parentheses. Boom. Then we're going to iterate through each possible target value and compute how many numbers could be made equal to it within the minus k up to positive k range and the limited operations. So we're going to say for target n sorted candidates, we're going to open up the brackets, and we're going to define the range of numbers that can be converted into the target by saying, first we're going to declare a constant and say let min range equal target minus k, and then we're going to say let max range equal target plus k. Boom. And now we're going to use a binary search for the first index, where the sorted of mid is going to be greater than or equal to mid range. So we're going to say, or we're going to come underneath this and start our binary search by declaring a variable called left, set that equal to 0. Then we're going to declare a variable called right, set that equal to n. Then we're going to say while left is less than, less than right. Then we're going to open up the brackets and we are going to say, y'all, let mid equal, open up the parentheses, left plus right, come outside the parentheses, divide that by 2. Then we're going to say if sorted square bracket mid is less than min range, then we're going to open up the brackets. We're going to say left equals mid plus 1. We're going to come underneath that and we're going to say else, open up the brackets, right equals mid. Boom. Then we're going to come underneath this while loop and we're going to find the first index where value is greater than or equal to mid-range. So we're going to create a constant and say let left idx equal left. Then we're going to come underneath that and we're going to create another binary search for the last index or the right boundary. So we're going to say, once again, we're going to set left equal to 0. We're going to set right equal to n. And we're going to say while left is less than right. We're going to open up the brackets. We're going to say let mid equal, open up the parentheses, left plus right. Come outside of that, divide that by 2. Boom. We're going to say if sorted square bracket mid is less than or equal to max range. We're going to open up the brackets. We're going to say left equals mid plus 1. Then we're going to come right here. We're going to say else. We're going to open up the brackets. We're going to say right equals mid. Boom. Then the first index where the value is greater than max range, we need to create a constant for that. So we're going to come right here. We're going to say let right idx equal left. And then we're going to compute the number of elements that lie within the min and max range by saying let window size equal right idx minus left idx. Boom. Then we're going to count how many numbers are already equal to the target by creating another constant. We're going to say let already equal. We're going to set that equal to freak map square bracket target comma default colon 0. And then we're still not done yet though, y'all, because now the rest in the range of the window size minus already equal could potentially be converted to the target using the operations. So we're going to handle that by declaring another constant called can transform. So we're going to say let can transform equal window size minus already equal. Boom. Then we're going to calculate the achievable frequency by transforming up to num operations. So come underneath this, we're going to say let freak equal already equal plus min, open up the parentheses, can transform comma num operations. Boom. Then we're going to track the highest achievable frequency across all targets by coming underneath this. We're going to say max freak equals max, open up the parentheses, max freak comma freak. Then we're going to return the maximum frequency found by coming right here, and we could say return max freak. Boom. Let's give it a run. Let's see how it runs. Okay, can I find? We got a typo, so let's just change this spelling real quick and let's run it again. Let's see, it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 268 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, before we go, make sure you get one more look at the code. This is the top part. This is the middle part. And this is the bottom of the middle part. And this is the rest of the code, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.